guys, welcome to the last video on this section about data types and objects in Python. We've been discussing some pretty concrete concepts in the last few videos, like what exactly those data types are and how you can go about manipulating them and using them. This video is more concept heavy. I'm not introducing a new data type, even though there are a lot more that you can discover in packages, and you can use other people's data types if the need be. But the ones we have discussed come as part of Python's standard library, and those are the ones most commonly used. And they have a special property, which is the core focus of this video, which is the debate between mutable and immutable data types. So under mutable data types are lists and dictionaries from amongst the one we have done, and under immutable are strings, numbers, and tuples, which we haven't done. But a tuple is essentially a list, is essentially the immutable counterpart of lists. Sometimes you need an immutable list, which a regular old square bracket list does not fulfill. Now what these basically mean are that immutable data types cannot be changed in place, and these can be changed in place. So what I'm going to do is basically show you what exactly I mean. So if starting with the immutable data types, so I said a string is immutable. So let's take a string equals string 1. Alright, so I made this string. I can look at it. Now I cannot go about changing the contents of this string. I cannot go about modifying the contents of the string. I can reassign a new value, an entirely new value to string, and that gets rid of the old value entirely. But I cannot go around modifying string 2. For example, if I want to remove this space, I cannot just say that string and then this space is at index 0, 1, 2, 3, 4, 5, 6. It's at index 6 and I want to remove it, so I just do empty string. It doesn't work like that. So I cannot modify this string in place. If I want to get rid of that that space, I'd have to do string equals string 2, and this is entirely different from what we're trying to do over here. This is me assigning a brand new value to this variable. So that's how the strings are immutable. I cannot go about changing them in place. I cannot remove this space simply by referring to its index and replacing it with an empty string instead of a space. So that's immutable. Same applies to a tuple. So I can have a tuple is equal to let's say 1, 2, 3, 4, 5. That's how you make a tuple. You make it with brackets instead of square brackets. So I have a tuple, and if I want to go ahead and I can of course I can access this stuff as I please. Tuple index 4 is the number 5, but if I want to replace that 5 with a 52, so I'm referring to that 5 over here and I want to replace it with 52. I cannot do that because tuple is immutable. I cannot mute it. I cannot change it in place. If I want to replace that 5 with a 52, I'd have to assign a brand new tuple to the variable tuple where 5 is a 52. Now my tuple looks how I want it to, but this is not the same as me manipulating or modifying the original tuple. So this has been immutable data types. Mutable data types include lists and dictionaries, and how we can mutate them is simply how we have been so far. So if I create a list equals 1, 2, 3, 4, 5, and I look at this list, now of course I can access that as I please, just as we have been, and I can replace this 3 with whatever I want. I can do list 2 equals 35. Now my list index 2 is 35. I could not do that with a tuple because a tuple is immutable, but over here I have modified the list to contain a 35 instead of a 3. It's the same list. So when I created this list, it got stored somewhere in memory, and when I passed this command, list2 equals 35, it modified the same list. It went to that address in memory, and it took out the 3 and it put back a 35 in its place, which is different from the way we have been quote-unquote modifying the tuples up here. So when I wanted to change that 5 to a 52, over here I created a tuple and it went and sat somewhere in memory, and I wanted to change that 5 to a 52, and that didn't work. So instead I created a brand new tuple and it sat somewhere else in memory, and then I took my variable tuple and I said point to this instead of pointing to the original tuple, and that's how I ended up with a 5 with a 52 instead of a 5, and my original tuple got deleted because it's no longer being used. Now of course a list has been modified. I can do the same with a dictionary, so I can create a dictionary with name Sabir and a date 14th of March. Alright, and so I've created this dictionary, and I can go ahead and change the values of this dictionary. I can change the date as I want, so I can change it to 15 March. Now if I take a look at the dictionary, it says 15 March. This is mutable, I can mutate it. So that's basically the difference between immutable and mutable, and it's important to know this distinction because sometimes in large programs you might have a mutable data type where you wanted an immutable data type. So some of your code might have changed a list in a way that you did not desire, and that can lead to some annoying bugs, so that you have to look for where that change occurred, and that's why the tuple exists. So if you know that you want a list to never change, you use the tuple, and nothing can change it apart from reassigning an entirely new value to the same variable. So continuing on the discussion of mutable objects have this property where the way they're assigned to variables is a little bit different. So for a string, let's say I'm going to make some space over here. I'm going to make some space. So let's say I have a string 1 equals string 1. Alright, and I'm going to say string 2 equals string 1. So essentially I'm creating a copy of string 1 and storing it into string 2. So now my string 1, oh, what happened here? So now my string 1 looks like this, and my string 2 looks like this. Of course, they're copies of each other. Now if I go ahead and change string 1 to instead say string underscore 1, alright, that of course changed string 1, but it did not change string 2, as is pretty obvious. String 2, of course it remains string 1. That's pretty obvious, but that's because these are immutable data types. How mutable data types like lists work is that they work by passing a reference. So if I were to create list 1 equals 1 2 3 4 5, and a list 2 is a copy of list 1, right? So list 1 looks like this, list 2 looks like this. Now if I will go ahead and change list 1, I put a 9000 at its index 1 instead of the 2. So now list 1 looks like this, but list 2 interestingly also looks like that, even though I never changed it. So what's happening here is that in this cell, in cell number 179, I don't know why that number is so big, in this cell, the process of creating a list happens only once. Remember that we used to create lists by surrounding data with square brackets. So this has happened only once, and that means that list 2 and list1 are both referring to the same list because only one list was created. In case of strings, because they're immutable, when I do this copy thing, it creates an actual copy of this string and stores it into this. So now there's two versions of string 1 which are stored in two separate variables. But over here there's only one string. Because it's mutable, there's only one string, and both of these variables end up referring to the same string by a pointer. So this one points to this string and this one also points to this string. They're both given, so the Python stores this string somewhere, stores this list somewhere in memory, and its address is given to both of these variables because this one was used to assign the list and this one was used to copy the list, copy the address to the list. That's why any change made to either of those will affect the other one as well. So to clarify, if I have list 1, it equals 1 2 3 4 5, and then my list 2, I'm not going to copy list 1, but I'm going to create the same list. Now if I change list 1, its index 2, I'm going to set it to 9. So now my list 1 looks like this, but my list 2 is unchanged. That's because the process of creating a list happened twice over here. So they're both referring to different lists even though they look the same. Python created a list two times, once here and then this was stored off somewhere in memory, and once here and then this was stored off somewhere in memory, and the address to the first list was given to list 1 and the address to the second list was given to list 2. So they are independent of each other. Over here only one list was created and stored off somewhere in memory, and the address to that memory location was given to both of these variables. The first time by direct assigning, and the second time by making list 2, the variable, refer to list 1. So yeah, this has been data types and objects in Python. So now you know the building blocks of Python, and in the next section we can finally get to putting these blocks together and actually make a building by adding logic to our code. Yes, your computer will start to think from the next section on. Thank you for staying this long with the All Text Python course. I have been Sabir, and I'll see you in the next section. Allah Hafiz.